Thanks for dropping in. In my last video, I created this 3D printed box that opens only when it transforms into a heart. The design uses built-in assembly tabs to avoid the need for glue or hardware. It's a nice trick that I've used in a few other models in the past, like this Shutterbox pencil case. In this video, I'll design another container using these tabs to demonstrate how they're created. Once you've learned the simple technique, you can use it in your own 3D printed designs. So let's jump to the computer. Okay, here we are in Autodesk Fusion, the CAD software I use for my 3D printed projects. If you use a different CAD program, don't worry, the overall concept will be the same. And if you're not familiar with 3D modeling at all, this should be simple enough to serve as an introduction. The first portion of this video is creating an empty shell to put the tabs on. Experienced modelers will probably want to jump to 4 minutes and 11 seconds, since there's not much to making half of a hollow box. Our first step is to draw a two-dimensional sketch of our container viewed from the top. We'll select Create, then Sketch, and click on the top plane. Now that we're in the sketch view, we'll draw a rectangle that represents the overall size of our container. The shortcut for this is R, or you can select Create, Rectangle, and two-point rectangle. Click once at the sketch origin to start the rectangle, and then click a second time to set the rectangle's opposite corner. The blue lines indicate that the rectangle isn't fully defined yet. Let's give it some precise measurements using the Dimension tool. Click D to open the Dimension tool, and then click the top of the rectangle to give it a specific width. For this example, I'll make the container 80 millimeters wide. Now we'll repeat that for the side of the box. Let's go with 60 millimeters. Next, we're going to draw a smaller inset rectangle that establishes the container's interior space. To do that, let's click O for the Offset tool. Now we'll click our first rectangle and set the offset to 4.8 millimeters. That sounds absurdly thick for a 3D printed wall, but it'll make sense in the end. Let's exit the sketch by clicking Finish Sketch and start building our box. To create the box walls, we'll use the Extrude tool, which you can get to with the shortcut E, or through the Create menu. We'll select the space between our two rectangles and pull this area down. I'm going to make this wall 30 millimeters deep. Once we hit OK, Fusion will create the wall and helpfully auto-hide the sketch we were using. Well, that's helpful sometimes, but we still need that sketch. So I'll go over to the Sketches panel and turn our sketch back on. If this feature annoys you as much as it bugs me, here's a bonus tip that even regular Fusion users might like. Go to your Preferences panel and turn off Auto Hide Sketch on Feature Creation. There, now Fusion won't auto-hide our sketches, and we can get back to work. This box needs a bottom, so let's bring up the Extrude tool again with E and select just the center of the sketch. In the Extrude panel, we can set both the height of the extrusion and its starting point. I want the bottom of the box to be on the bottom, so let's set the start point to Offset and give it an offset of -30 millimeters. That's the same height as the box wall. Now for the extrusion distance, I'll enter 1.2 millimeters. 1.2 millimeters works well for those printing in either 0.2 or 0.3 layer heights, so I use this value often when designing flat surfaces. Hit OK, and we finally have one half of the box. Welcome back to those who jumped ahead to the tab portion of the video. You got here just in time. First, we need to define where the tabs will be around the edge of the box. Let's right-click on our original sketch and select Edit Sketch. The tabs are half the thickness of our container wall, so we'll bring up the Offset tool again with O and create a new inset rectangle that divides our 4.8 millimeter outer wall into two 2.4 millimeter halves. Now we need to draw some lines that will define where the tabs start and stop on each edge of the container. Click L to bring up the Line tool and draw 3 horizontal lines that run all the way across the width of the container. Then draw 3 vertical lines. chances are Fusion will automatically detect that you were drawing lines that were perpendicular to the sides of the container. If it did, you'll see these small perpendicular constraint icons near the start of your lines. If Fusion failed to do this automatically, you can use the perpendicular tool in the constraints menu to force these lines to be perpendicular. Now we need to define the position of these lines. Using the dimension tool with the shortcut D, I'll set both of the outer vertical lines to be 8 mm inset from the container's edge. We need the middle vertical line to run perfectly down the center of the container. We could use the dimension tool for that as well, but I'm going to go back to the constraints menu and select the midpoint tool. With this, I can specify that the end of this line falls on the midpoint of the top of the container. Now we'll repeat this process with the horizontal lines. We can finally click Finish Sketch and make some sense out of these new lines. Bring up the Extrude tool by clicking E, and then select the areas that will become our 4 raised tabs. Enter 4 mm for the extrude height and hit OK. Now we need to create the grooves these tabs will slide into. So bring up the Extrude tool again, select the sections adjacent to our raised tabs, and enter -4 mm for the extrude height to cut a thin trench. If you selected the correct areas for both extrude actions, you'll have half of a box that, if printed twice, could slide together to form a hole. But there are 2 immediate problems. The walls for the shell are too thick, and the tabs are relying only on friction to hold the assembly together. Let's bring back our sketch and take care of that thick wall. Using the Extrude tool with E, we'll select everything except the outermost wall of the box. Now we'll set the start of this extrusion to offset, and give it a value of -28.8 mm. That's 30 mm for the height of the box, minus the 1.2 mm floor. Then we'll set the extrusion height to 22 mm. This cuts a nice chunk out of the box interior, leaving the thicker sections of the wall only for the area around the tabs. Speaking of tabs, we need to give them some real grip. Let's bring the sketch back one last time. Right-click on it and select Edit Sketch. We're going to use the Offset tool again with the shortcut O, and create a new offset rectangle from our container's edge. This rectangle should be inset 2.8 mm, just a little further in than the offset we created for the tabs. Now we'll click Finish Sketch one final time. We'll use this updated sketch to carve out some little hooks into the raised tabs. Bring up the Extrusion tool with E and select the 4 sections shown. We'll extrude these profiles up by 2 mm. If that was done correctly, you'll have 4 hook-shaped tabs. We'll need to repeat this with the tab slots, this time adding a little lip to those slots to hold the hooks in. Bring up the Extrude tool and select the 4 small sections that correspond to the 4 tab slots. For this extrusion, we don't need to set up an offset value. Just extrude down 2 mm and click OK. Alright, we have some secure clips, but we're not quite done yet. This current design has way too many overhangs and too many tight fits. So in the next section, we're going to make this box easier to print. Let's add some clearance to the raised tabs so they can actually fit in their intended slots. For this, I'm going to use the Press Pull tool, which is in the Modify menu. We'll select both sides of all 4 raised tabs and inset them by -0.2 mm. Make sure that you're actually pushing these surfaces in. If you make the tabs wider, they're not going to fit at all. Next, let's take care of some overhangs using the Chamfer tool in the Modify menu. The interior ridge of our box is a nasty 2.4 mm overhang, so we'll select all these edges and give them a matching 2.4 mm chamfer. Let's repeat that step with the 0.4 mm overhangs under the 4 raised tab hooks. And we'll do that again with the 0.4 mm overhangs above the tab slots. The chamfer tool can also help us make the tabs a little easier to handle. Let's select the top surface of our 4 raised tabs and give those a 0.4 mm chamfer as well. This will help guide the tabs into their designated slots and give the assembler just a little extra wiggle room. Last but not least, I'm going to throw in some purely cosmetic tweaks. A 2.4mm fillet will help round out those sharp corners. A 0.4mm chamfer around the bottom edge will help compensate for printers that excessively squash their first layers. Inside the box, I'll add a 1mm chamfer along the base of the wall. This helps with common printing artifacts that pop up around sudden floor-to-wall transitions. Okay, this simple snap-together box is ready for the printer. One print later, and we're ready to assemble. I'll just line up one side like this, and then force the box closed. As you can see, this assembly is incredibly tight. You may need a clamp to force the halves together, and you'll definitely need tools if you want to take it apart. If you want something a little more loose, these tabs could work, but you'll need to add some extra clearance. And keep in mind that a 3D printed tab will only be able to flex so many times before it breaks off. This demo box is a little useless because I didn't even model an opening. But you can download both the print files and the original Fusion design file for a better understanding of how it works. Since this is a teaching model, the files will be shared under a Creative Commons public domain license. Use the files for whatever you want, including commercial use. Of course, if you do make something with this technique, I'd love to see it. Until next time, happy printing, and thanks for stopping by. Well, I fell for it again. I thought I'd make a quick tutorial video for this week, and I totally forgot that they take way longer to script and edit than a normal video that includes a brand new model. Still, I hope it was useful, and if this is something that you want to see more of, definitely let me know. Otherwise, I'm only going to make tutorial videos when I totally forget how much work they are. Alright, see you next time.